Castellanos, and this is the second part of the evidence of physics, matter and energy. In the first problem, they are asking us for the frequency and the period that it takes. So, for the frequency, we use the formula frequency equals to angular velocity over 2 pi, and angular velocity, like the problem says, is 60 revolutions per minute, and that's over 2 pi, and that gives us 9.54 hertz. And for the period, we use period equals to 1 over frequency, and that gives 0.10 seconds. For the second problem, they are asking us for velocity, and they are giving us the frequency, which is 300 hertz, amplitude of 2.2 millimeters, and that we pass it to meters, so we have 0.0022 meters, and the displacement, which is 1 millimeter, and we use the formula velocity equals to 2 pi times frequency times amplitude, and that gives us 4.14 meters over second. For the third problem, they are asking us for work and the potential and energy acquired by the spring. So we clear the data, which is the displacement is 35 millimeters, and that passes to meters, and that gives us 0.035 meters. The constant, which is K, is 190 newtons over meter, and the displacement, well, we know the displacement, sorry, and we use the formula of force, which is equal to minus K, and that means the constant, times the displacement, which is x, and that gives us minus 6.65 newtons. Then we take the potential energy, which is with the letter U, and is equal to 1/2 of the constant times the displacement to the square, and that gives us 0.116 joules. Now we take the work, and for that we use the formula work is equal to force times displacement, and that gives us minus 0.23 newtons. In the fourth problem, they are asking us for the velocity, and they are giving us the mass, which is 1/2 kilogram, the length 0.5 meters, and the force 100 newtons. And for that we need to take the mu first, and the formula is mass over length, so that gives us 1, and then we take the velocity, which is square root of force over mu, and that gives us 10 newtons. In the fifth problem, they are asking us for the mass, and for that they are giving us the length, which is 4 meters, the force, which is 300 newtons, and the velocity, which is 150 meters over second. And we need to clear it for velocity first, and the formula is velocity equals to square root of force over mu, and then we need to clear the square root, so we pass the square root to the other side, and we have velocity squared equals to force over mu. Now we need to take mu, because we need to know with the formula mu equals to mass over length, and clear it, and we got the mass. So returning to mu is equal to force over velocity squared, and that gives us 0.013. Now with the formula I mentioned first, is mu equals to mass over length, and we clear for mass, so we got mass equals to mu per times length, and that gives us 0.053 kilograms. sixth problem, they are asking us for time, and they give us the length, which is 2.5 meters, the density of the copper, which is 8,800 kilograms over cubic meters, and the elasticity, is used with the letter Y, and is 1.70 exponent to the 11 pascals. Now we need to clear the formula of the velocity, and is velocity equals to square root of y over density, and that gives us 3,646.29 meters per second. And now we need to take the time. That is what they are asking us, and is velocity equals to length over time, and then we pass time of the other side, and that stays like time equals to length over velocity, and that gives us 6.85 exponent to minus 4 seconds. In the seventh problem, they are asking us for intensity, and they are giving us the dV, which is 55 dm. And I use the formula V equals to 10 logarithm of intensity over intensity 1, then I clear intensity, so that stays like intensity equals to intensity 1 times 10, and to elevate it to the V over 10, and that gives me the result 3.16 exponent to minus 7 W over square meter. In the eighth problem, they are asking us for frequency, and they are giving us the frequency 1, which is 560 Hz, the velocity, which is 60 kilometers over hour, and that we need to convert it to meters per second, and that is 16.66 meters per second. Now we use the formula frequency equals to frequency 1 times the velocity of the sound, which is 343 meters per second, over velocity of the sound plus and minus of the velocity, and when it goes away is 588.58 seconds, and the frequency when it gets closer is 534.05 seconds. In the ninth problem, they are asking us for frequency again, and they are giving us the velocity that is 72 kilometers over hour, and that has 2 meters per second and is 20 meters per second. The frequency, which is 330 Hz, and the velocity of the sound, which is 343 meters per second. Now I use the formula frequency equals to frequency 1 times velocity of the sound over velocity of the sound plus and minus velocity, and when it goes away is 350.43 Hz, and when it comes closer is 311.81.